All right, great. So what we've just done is figure out how to solve the problem that you get a call from your CEO. Let's say that you work at the Pontiac factory and Mary Barra calls you up and says, hey, we want 20,000 Pontiacs this month. We figured out how you're gonna decide how to produce those Pontiacs as cheaply as possible. What we're gonna do next is we're gonna use those tools to answer the question, how much would it cost to produce an arbitrary number of Pontiacs? And this is gonna be useful because then when you're the CEO and you wanna decide how much to produce, you need to know how much it would cost to produce an additional Pontiac, right? How much 20,000 costs versus 30,000 versus 40,000. Excellent. So how we're gonna do that is we're gonna adjust our problem-solving technique that we just learned in the same way that we adjusted consumer optimization to find demand functions. In other words, we're gonna figure out the cost of producing, instead of 4 tons of potatoes or 40,000 Pontiacs, let's figure out the cost of Q tons of potatoes. Right, so our goal is to know the cost of Q units of output. And we're going to do that by figuring out, right, the amount of labor we're going to use to produce Q units of output and the amount of capital we're going to use to produce Q units of output. Let's do this with the same problem we've been working with, right? So let's imagine that we've got a wage rate of 20, a rental rate of 5, and a production technology that's equal to L to the 1/2 times K to the 1/2. Awesome. So how are we going to go about this? Well, we're still trying to do exactly what we did before, except now we're trying to find the solve for our optimal choice on the isoquant Q equals Q instead of Q equals 4. So what we'll do is first, we'll set our MRTS equal to our price ratio, right? In this case, that's very straightforward, right? We said that our MRTS equal to du, df, oh, I'm sorry, my goodness, df, dl over df, dk. And we already solved it, right, to be k over l. So we say k over L equals W over R, right? K is going to equal W over R times L, which in this case is going to be 4L. And then we plug that into not our specific isoquant, but our generic isoquant, right? So then we'll say L to the 1/2 times K to the 1/2, instead of equaling 4, equals Q, right? So L to the 1/2 times 4L to the 1/2 equals Q, right? 2L equals Q, L equals Q over 2, right? So there we go. So the first thing we've already solved, right, is we've got L as a function of Q equals Q over 2. Then we can say K equals 4L. So that's going to give us, right, K as a function of Q is going to equal 4 times Q over 2. So it's going to be 2Q, right? L of Q equals Q over 2. K of Q equals 2Q. So far, so good, right? So now we know how to produce Q units of output as cheaply as possible, right? We'll use Q over 2 units of labor and 2Q units of capital. So the only question is, right, how much does that cost? How much does it cost to hire Q over 2 units of labor and 2Q units of capital? Well, remember what any amount of labor and capital costs is just C of L and K is going to be WL plus RK, right? So therefore, the cost of producing LQ and KQ is just going to be W times the amount of labor it takes to produce Q units of output as cheaply as possible, plus R times the amount of capital it takes to produce Q units of output as cheaply as possible, right? So our cost function in terms of Q, will just be this, right? So it'll be 20 times Q over 2 plus 5 times 2Q, right? So this is going to be what? 10Q plus 10Q equals 20Q. So what's this telling us? Tells us that to produce any amount of output we want, right, Q units of output, it'll cost us $20 times the amount of output we want, right, 20 times the number of potatoes we want to grow. So this is the deal, right? This is how we're going to solve cost functions, is we're just going to solve a cost minimization problem for an arbitrary value of Q. That's going to give us the amount of labor and the amount of capital it takes to produce Q. And then we'll find our cost function just by asking, how much does hiring L of Q units of labor and K of Q units of capital cost? Cool. Now, there's something I want you to notice, though, about our answer, right? Cost of Q units of Q tons of potatoes is 20 times Q. So if you remember, right, when we talked on Tuesday, we talked about increasing returns to scale and decreasing returns to scale. And we used a production function that looks a whole lot like this. In fact, it might have actually been this production function to illustrate the idea of diminishing returns to scale. And yet here, right, if we think about the scale of production, if we don't think about the, what happens when we add another worker, another worker, another worker, but instead we think about if we want to grow another ton of potatoes, another ton of potatoes, another ton of potatoes, what we're learning is each and every potato we grow is going to cost us $20, right? It doesn't matter if we grow 1 ton or if we grow 1,000 tons. Another way of saying that, right, is that the effect of our scale of production is non-existent, right? Or we could say that we have constant returns to scale. Now, why is this? Can we understand why we're getting this constant returns to scale result? Right, the fact that our cost is just a linear function of Q from what our production function looks like, right? From the fact that we've got f of LK equals L to the 1/2 times K to the 1/2. We can't. The reason for this is, let's imagine that I double my inputs, right? So I double labor and I double capital. So let's say I wanted to know how much I produce with 2L and 2K. Well, it would be 2L to the 1/2 times 2K to the 1/2, right? If I distribute the 1/2s, this is just going to be 2 to the 1/2, L to the 1/2, times 2 to the 1/2, K to the 1/2. In other words, this is just going to be 2 times L to the 1/2 times K to the 1/2. In other words, when I double my inputs, I double my output. And that's why, right, I've got constant returns to scale. Because doubling my inputs doubles my cost. So to produce twice as many potatoes, I need to outlay twice as many dollars. Cool. So in the next video, we're going to spend a minute talking about the concept of returns to scale, what it looks like graphically, and how it's going to be reflected in different production functions.